Not last and certainly not least is Marissa Martinez. She's a sophomore who found a really cool idea when she was surfing through some of our science news magazines that we get from SSP, and she ran across an interesting idea about toxicity on trout. And so I'm going to let her take over. Marissa, are you ready?
I get to talk about science. Yeah.
That's it, girl.
Okay. Well, let me just open share screen here. Wrong screen. That one. Share. Okay. Whoa, it's so slow. Okay, there we go. Oh. Okay, let's see. Oh, I need to like move these over here. Okay, present. Okay, so I'm Marissa Martinez, as Harvey said, and this year I did Traveling Trout, the viability of trout eggs along the mainstream of the geothermally altered Alamosa River watershed. So in the past years, the Alamosa River has been subject to naturally occurring toxins. So the river flows through hydraulically thermal altered rock formations. So here in this image here, you can see the littoral caldera, and basically the Alamosa River flows directly in the middle of this. But as it flows through the middle of this, it tends to pick up large amounts of pyrite, and when this pyrite mixes with the water, it essentially turns it to acid. So as the river's flowing, it essentially, how do I say this? It eats away at the minerals within the soil, and it adds to the metal concentration load within the river. So the Summitville mine, definitely popular. It was typically mined for gold and silver. However, in the 1980s, their clay liners failed and they broke. And this unleashed millions of gallons of highly mineralized water into the underground aquifers and the downstream watershed, which is the Alamosa River. And this essentially killed most life, including the trout. So due to the natural acidity and the Summitville spill, I became interested in seeing if I could possibly reestablish trout within the Alamosa River. And if I could, I wanted to see if the eggs could realistically survive and how far they could along the river. So the purpose of this experiment was to examine trout eggs when exposed to different sample locations along the Alamosa River. So I wondered how far upstream the trout eggs could realistically survive and which sites are the healthiest in terms of water quality and metal concentrations. So I had hypothesized that the trout eggs would have a higher viability the farther downstream the sample was collected, due to the fact that the lower Alamosa River, it initially receives a lot of healthy water from healthy side tributaries, and also that the trout eggs exposed to the sample locations closer to the toxic tributaries would have the most unsuccessful survivorship due to the low pH levels and the high amounts of metal concentrations. So basically, in order to carry out my project, I tried to create a hatchery-based water filtering system. So what happened was I got to go to Carbondale and I got to go to Crystal River Hatchery to go pick up my eggs. But the cool thing is that while I was there picking up my eggs, he gave me a tour of his facility, the CPW manager there, and I got to see this like really cool development chart of the eggs in their exact stage at which they were developing. And I also got to see the eggs that they had just produced, and it was pretty cool because I actually got some of those eggs. But I had got to see their filtration system, and basically it was these kind of squarish rectangular boxes, very shallow, and they had a whole bunch of eggs in there. And basically water would come, it would come from the underneath and it would filter through, and they had kind of a mesh net on the top, and it would just continuously do this, getting rid of metallic waste and buildup and all that. So that's what I tried to mimic. So in order to do this, I had collected my water samples from 7 different sites, and I then created egg chambers, and I did this by using beakers, nylon mesh fabric, and zip ties, and I had raised this just above the bottom of the beaker, creating a net to allow for aeration and water circulation throughout the beaker. And I then used aquarium tubing and aeration stones to set up my filtration system. And I then capped these beakers with a solo cup that held the aeration stone in place while preventing cross contaminations between beakers. That. So I then put these beakers into the refrigerator, and the CPW manager had told me there that they keep their eggs at 52 degrees exactly. So I tried to do this the best with a thermometer. So I had done that throughout the course of the project. And I then had to see through to daily water changes. So every day I would come into the school and I basically would take out 100 milliliters of water from each beaker, and I would replace it with their site-specific fresh water, basically, you could say. And I did that for 4 months. And then I conducted water chemistry on pH, nitrates, nitrites, ammonia, and phosphates. And I did this on days 1, 14, 21, and 25. So here you can see the map. On the left of the map is the upper Alamosa River. On the right is the lower Alamosa River. So here you have Iron Creek, Alum Creek, Bitter Creek, Whiteman Fork, Jasper, and Burnt Creek. These are all unhealthy tributaries coming into the Alamosa River. And then down here towards the lower Alamosa River, we have a bunch of healthy side tributaries coming in. And of course, these dots here are where I collected my sample water from. So basically, what I had done first was I had collected an average survival rate per sample location. So basically, how many eggs had survived out of 75 that were given for each sample location. So we have above Iron Creek, as you can see, they had the highest survivability rate. And then we have Government Park, had the worst survivalship rate. And then we had below Whiteman Fork, relatively low survivalship rate here as well. And then above Rough Creek, relatively higher survivalship rate. And then Silver Lakes, I had some unexpected results here that I'll elaborate more on. And then we have here above Terrace Reservoir, had the second highest survivalship rate, and then the Miller Residence, fairly high survivalship rate, and then Hatchery, which was also unexpected, but I will explain some of that later. And then here, I also conducted t-tests between my groups. And these can be shown up here. So basically, here, if they have a single letter, it means that they are significantly different from all my other sample locations. However, if they have two, they are not significantly different from that site that they're being compared to. So then I had taken it a step further, and I had looked at all 600 of my eggs under a microscope, and I determined what development stage that they were in. So I have week 1 of development, which is egg no fish dead. Week 2 of development, egg with small fish, no eyes dead. Week 3, egg with large fish with eyes dead. And week 4, egg with live fish. So as you can see based on this graph, majority of it is purple and turquoise, meaning that my eggs had either most likely died in week 1 of the experiment, or they had made it to the living stage in week 4. And then, oh shoot, that wrong arrow. And then I had included a development chart here for reference. However, it's not as cool as the one I saw as the hatchery, but it'll work. So here's week 1 of development, week 2 of development, week 3 of development, and week 4 of development. And I, of course, didn't do these stages because we can't let them grow to actual fish. And then I had conducted water chemistry, so I had tested for ammonia. So basically, ammonia, the recommended level should not exceed 2 parts per million. However, if you look at this graph, you can see that Government Park, however, did exceed 2 parts per million. And then below Whiteman Fork approached, however, it and the rest of my sample locations remained below the toxic level. And then here, I tested for average phosphates. As you can see, they jumped around quite a bit. However, they were all well below the toxic level. Phosphates, they're generally tied with algal blooms, meaning that in a river, if there's a whole bunch of algae that blooms, it essentially reduces oxygen within the water. However, that wasn't the case here because I didn't have a river or actual algae in my beakers. And then we go down here to average pH levels. So as you can tell right off the bat, Government Park is all lonesome down here, definitely very acidic. And then we have Whiteman Fork and Rough Creek approaching acidity. However, the rest of my sample locations remained at a neutral pH throughout the course of the project. So I had then tested for metals, and green here is not toxic, yellow is approaching toxic, and pink is in the toxic level. So we have Government Park, below Whiteman Fork, above Rough Creek, and Silver Lakes at toxic levels for aluminum. And then Government Park also had additional toxic levels of copper, iron, and zinc. And then below Whiteman Fork had additional high concentrations of copper and zinc as well. And then above Rough Creek and Silver Lakes also had additional high concentrations of iron. And then we come down here and I did initial water chemistry. So I tested for pH once again, and then phenolphthalein alkalinity, total alkalinity, and total hardness. And as you can see in Government Park, definitely acidic. Below Whiteman Fork, above Rough Creek, and Silver Lakes, approached acidity. And then phenolphthalein alkalinity, total alkalinity, and total hardness remained well below the toxic level. And then, so basically overall, what I'd found was that above Terrace Reservoir, above Iron Creek, and the Mill residents, they all had the most successful survivorship rates, and both pH and the metal concentrations remained well below or approached toxic levels. Also below Whiteman Fork, above Rough Creek, they had slightly higher survivorship rates, well, slightly lower survivorship rates actually, and they both contained high amounts of aluminum. As I had mentioned, below Whiteman Fork had additional high concentrations of zinc, and above Rough Creek had additional high concentrations of iron. And I feel like their low survivability rates can be due to the fact that they had they both had slightly acidic pH values, of course, mixed with the high metal concentrations. I think definitely could have played a factor in their lower survivability rates. And then Government Park and Silver Lakes definitely had the worst survivorship rates out of all my sample locations. They both contained high amounts of aluminum and iron, and Government Park had additional high concentrations of zinc and copper. So basically, Government Park, I had expected these results due to the fact that the Summitville spill had actually run down this, and it's really toxic. Definitely had the highest amount of aluminum. And Silver Lakes was a little bit unexpected due to the fact that it had a very neutral pH throughout the course of the project. However, I think that with additional testing, it would be cool to see what's happening there. And then Crystal River Hatchery. So I had tested their water as another one of my controls, as well as the above Iron Creek water. And their results were rather surprising to me due to the fact that they produce eggs in large quantities daily, and the CPW manager had told me that their survivorship rate is higher than 95%. So whenever I got my low survivorship rate, I was like, well, what the heck? Because the pH levels were very neutral, and all metal concentrations were extremely low. So I think that it could be on my part, though, due to the fact that whenever I had set up my beakers into the refrigerator, I had run out of room to put them in rows. So I had to place these beakers specifically at the back of the refrigerator. And I think it's possible that it could have been colder back there, and the colder temperatures definitely could have caused for lower survivability rates. So overall, I had found that the trout eggs realistically cannot survive between Iron Creek and the Whiteman Fork tributary. Also, that egg survivorship above Rough Creek is debatable due to the fact that I don't know if the eggs would be able to survive the toxic runoff coming from Jasper and Burnt Creek, because I couldn't get my samples directly from there due to the fact that it's private property. So that's why I had to get samples lower downstream. And then Silver Lakes, as I'd mentioned, definitely really weird results there. But I think it would be cool to do additional testing and see what's going on there. And but I do believe that the trout eggs can survive from the Miller residence, extending to above Terrace Reservoir. I had also observed that high metal concentrations, particularly aluminum, as I had mentioned a lot, seem to negatively affect the eggs and decrease their viability rates. Also, I had also noticed that pH can definitely have an impact on the toxicity of metals, and I think that this can be an additional factor in survivability stretch between different tributaries. And I definitely think that this study can be beneficial to Colorado Parks and Wildlife in terms of restocking and the restoration of the lower Alamosa River. I think it's really cool that my research kind of adds on to newer research on the Alamosa River. I know that there's a whole bunch of research out there above, like about after the Summitville spill and all this, but I think it's cool to know that I'm kind of contributing to the more recent area of this topic. But this was definitely the coolest thing I've ever done. I'm definitely looking forward to doing more stuff with it in the future. But I know that there's a whole bunch of stuff to be done with Alamosa River because I barely touched what could be done there. But yeah, so that's it. That's my bibliography, so I'm open to questions.
Great job, kid.
I was a little nervous.
You're fine. We're all friends here. We love you.
Oh, I know.
That's awesome.
It was just a little nerve-wracking. Let me like pop up this. Okay. Yeah.
Maybe I'll start, Marissa. Absolutely fantastic. And it really does model what
CPW biologists are doing in terms of thinking about restoration efforts and where that's going to be most successful and what are the implications and how do you deal with legacy mining and influences all over the place, and are there segments that could be repopulated while downstream segments are, you know, threatened due to, you know, tributary and its influence. So really neat. Help me just with your study design. So you have all your beakers, they're sitting in the fridge. Maybe the hatchery ones are forced to the back, but like that's all. I mean, those observations are so critical to science. And I'm so glad you know, have some hypotheses about what this looks like.
Thank you.
He wants to ask you about your methods too. So can you tell me a little bit more about, your methods and that exchange of water? You said every day you'd exchange 100 mils of water?
Yeah, so basically, so I would take out like a group of beakers, and I had a 10 milliliter syringe, and I would basically just keep on pipetting until I got 100 milliliters out of each beaker. And then, so basically whenever I went to go collect my water samples, I had collected 15 bottles from each sample, and I had, whenever we came back, I put them into the fridge to keep them at the temperature that the eggs were in, just to keep it more neutral, I guess. But so I would get some of that water out of the fridge, and I would then pour 100 milliliters into each beaker. And then I would, of course, put them back and then put the filtration, the aeration and stuff. But yeah, so I did that every day. And yeah, did that answer that?
Yeah, that's helpful. I mean, that exchange, and Lori was singing your praise and talking about this method for keeping your eggs off of the bottom of your beaker.
Yeah.
Can you talk about that a little bit?
Yeah, so basically, we had came up with that idea just because, like, it was basically, well, the water exchange too was to try and avoid metabolic waste buildup. So that's why we didn't keep them on the floor directly, because of course if there was metal contaminants in there, they would sink. So the eggs would be more exposed to that kind of stuff. And of course, to allow for more filtration also, I guess, for that stuff to swirl around the beaker. But yeah.
Yeah, I think it's a really neat idea. Pete, do you want to jump in here? Well, maybe I'll just
did really good. I've spent a lot of my life picking eggs out of little cups to see who responded to what metal, and it is tedious, so well done. You know, in my comment I said for decades the field of toxicology has just worked with mature fish. And why? Because they're not creative or they're lazy. And you chose a sensitive life stage and investigated. So you be really proud about what your methods were and how you did it. I am kind of curious, what would you do differently? You said you were worried about some temperature changes in the back of the fridge, and you had a couple other things in there where you probably learned, oh, maybe next time I'll do these methods different. What are you going to do next time if you get an opportunity to rerun a test, maybe asking a different question, but working with these organisms at these life stages?
Well, if I were to definitely like try and do this again, I would definitely try and keep track of the temperature, but it was a little hard to do that from the first place because we had the refrigerator up in the greenhouse, and at the time the school was having some major heat problems, so it was getting really hot. So we had to open up the door, and then one time someone accidentally left the window open, so it caused a little bit of freeze at the back of the fridge, and I think that definitely also could have affected the hatchery beakers. But other than that, like I think it would be really cool because I had collected my samples in late fall, so of course that's when there's a whole bunch of the metal is very concentrated because there's not a whole bunch of healthy runoff coming in. So I think it would be cool to try and compare results maybe in the springtime when of course there's healthy runoff coming from snowmelts and all this. I think it would be cool to compare results like that. And then, yeah, I need to put more thought into how I would try and design it better though, because that's a little tough. The idea of that, but I feel like it'd probably be something similar to what I have, because I think it worked pretty well, other than the fact for the temperature fluctuations. But yeah, so I'd have to think about that. That's really good. Kind of stumped me.
Well, you know, you just said you do it at different seasons. I'm going to point out that's more environmentally relevant. Do you know what I mean by phenologically?
Sorry, you cut off. I didn't hear the first part.
Okay, you just said you do it at different times.
Yeah.
And then I threw a big word. I said, well, phenologically, you've timed the development of the correct organism with your metal collection.
Yeah.
What do I mean by that?
Like, well, because like it kind of worked out perfectly, because the eggs are being introduced to the worst water over the year, you know, the worst part of the year. So if they're able to survive in that water, then they can clearly survive in water at different seasons.
That's an excellent approach to risk assessment. Well done.
Thank you.
Other questions, anyone?
I will throw this in there because this just made my day. So when we drove up to Carbondale, we met with Rob Streeter. That's the manager there. Phenomenal guy, just so friendly and so helpful. And I just sing his praises. He was amazing how he was willing to just support a student just kind of out of the blue. We had been emailing back and forth and he's like, come on up, we got a bunch of eggs. So, but when he was very concerned, he really pretty much doubted our ability to keep any eggs alive. So he had a lot of, he prefaced every statement with, don't do this and don't do that and make sure you do this, you know. So we had this litany of we were scared, like we were afraid to move them and afraid to bump them. And, you know, he really painted a picture of them being very delicate, especially in the first like 72 hours right after hatching. Mm-hmm. So we were really careful on the way home. We drove slow, you know, and we got here and we were able to pipette them all into the beakers. But he had talked about, he was really worried about the eggs sitting on glass, that was going to really reduce their aeration and create dead spots on the eggs. So Marissa and I got to talking on the way home about how to troubleshoot that. And that's where we came up with this mesh and zip tie thing. And when we sent the pictures to him and she told him about her survivorship rates, he was like, you are kidding me. I think he was convinced he was just sending 800 eggs to their doom and this just wasn't going to work. And he was absolutely blown away. And he gave Marissa just the best compliments and got really excited about, you know, beakers with mesh, which at the time seemed like a simple fix, but apparently nobody had thought to do that. So I gave Marissa a lot of props for coming up with that. I think that's awesome.
That's very cool. So you mentioned the surviving eggs, right? You couldn't let them get full grown, obviously.
Yeah.
What was the instruction you got as far as that? Like, how do you dispose of them? What do you do with them?
So I was like, oh, well, I was really sad because like they were kind of basically my kids. Like I had taken care of them for like a month. But just because of science fair guidelines, we can't let them get to an actual fish, I guess.
Yeah, technically they turn into a vertebrate the day they hatch. So they are not technically vertebrates as long as they're in the egg stage. So that's the fine line we walked. We couldn't let them go all the way.
Yeah, so I had a choice between either boiling them after I was done or putting them outside to freeze. So I was like, I'm not gonna boil them. I was like, can we just leave them outside? So yeah, so we just left them outside overnight, and yeah, and then they just all died. So yeah, it was sad.
Oh,
I did feel bad about that.
The sacrifices you make for science,
right?
Yes.
Mm-hmm.
Yes.
I mean, wow, that's so cool. I've learned so much. I don't think I have any other questions. If anyone else wanted to chime in.
I have one simple one. I noticed you showed total concentrations of metals. Is toxicity related to total or dissolved metal concentration?
Well, I had both because these lovely people gave me both. But on my graphs, on my slides, I had only used total.
Okay, thanks.
Yeah, you're welcome.
And great job, by the way.
Thank you.
Any other questions? Cool. I mean, yeah, like I said, I'm just so impressed. Lori, great job. Obviously the kids, students, great job, and keep it up. I mean, this is incredible. I've learned so much.
Well, and I just want to say thank you. I mean, I'm always gushing about how amazing Riverwatch is and how you guys just so willingly support us kind of straying outside the lines, letting us, just really use the program in a creative way instead of we're just going to go monitor our site every other month or every month, I think that's the exciting part about what we're doing. And we're contributing hopefully to the massive database that you guys have. And even if it is something that we only do 1 year or every other year, or, maybe we only revisit it every 5 years or something like that, those sites are now on the map, and some interesting comparisons can be made if anybody does decide to pick up these sites and do something with them in the future, or kids want to do a follow-up study, my next crop of future and upcoming scientists, so just tons of potential, and it wouldn't be possible without all the work you guys are doing. Please know how important the work you are doing is. I cannot stress that enough. I mean, we volunteer, but we're volunteering. We're going outside. Of course, we're going to volunteer to go outside and collect water, but you guys are doing the heavy lifting, and you guys are the ones up there, talking to the Denver water people and getting the funding and finding those, nonprofit partners. And that's phenomenal. I'm truly, from the bottom of my heart, thank you.